So moving on to actually measuring, we'll just do a very quick basic measure so you can just get a feel for how to take off, and along the way I'll explain to you what I'm doing and why I'm doing it, and hopefully you can follow along. I've provided you with these two files, well, let's get those in. So just browse, elevation and plan. Okay, first thing we do is calibrate. We don't have any values to copy or dimensions on this particular drawing, but we know it's a 1:50 scale. So if we go up into the measurements dialog and we set our scale 1 to half a metre, as explained before, is 1:50, tick the box, precision set at 0.01, and incidentally in version 19, which has just come out, this all appears in the dialog box, the pop-up box, and also if you go to measure any drawing without calibrating, it will prompt you to calibrate. So it's quite an enhanced feature, but that's calibrated, that one. And also I'll explain to you the fact that your Swift have a company license, or your company has a company license. What you can actually do, you can apply to Bluebeam for a personal home user license, and it's about currently it's about 90 odd quid, 100 quid, and all you have to provide is your original registration number that Swift hold as a registrant of the software, provide a separate email that's not a work email, and they will give you a home copy for your use outside of work. And the added benefit of that is every time there's an upgrade, you'll get the latest version without having to pay for it, which is really, really handy. So anyway, cracking on with measuring. Calibrated this on this section here. We're going to use one of these dims, so either go up to measure, pick calibrate, or come over to the right hand menu if you have it, click on calibrate. Your dialog pops up, select 2 points. Let's grab this line here, .05, make sure it's meters, store. Okay, both now set. So let's first grab the perimeter of this for our splash. Go into your tool chest, wall types, girth, perimeter at DPC level. I always annotate my tools with girth or area, so when I'm actually using them and when I export them into a spreadsheet, I can differentiate between how I've measured. Let's just grab the girth of this little plot here. All the way around, double click to finalise, and you can see there's our girth. Now if there were guts walls in here, you could just take those off at the same time. If you had a plinth, you could measure your plinth on plan. Anything else you need to do, fire barrier locations as counts, however you want to measure, you can measure. I'm just keeping it nice and simple just for demonstration purposes. Pop back to our elevation. So we've stored the scale in the page. Doesn't hurt to double check. So find a door, and generally they're 2.1, just by way of a check. So we're there or thereabouts. You can see we've got 2.07. Zoom in and get a bit more accurate. Grab the node, drag it down. Yeah, 2.1. So we're there or thereabouts. So wall type area now. So we're going to assume that this is stretcher-bond. So all I'm going to measure here is just the outer skin brickwork through the wall, the lintels, the closers, a few bits. So I'll just whiz through and talk while I'm doing it. I'm assuming a couple of courses up behind the fascia and measuring down to damp. Don't have a particular section for this one, so we're just, as I say, just keeping it simple. But you best to double check through your section. Sometimes your plates obviously go higher on the inside. And I'm going to add my DPC splashes in from the girth I've taken on the other plan. Staying in the same tool. We drop it about there. Obviously there's going to be block work in behind that little roof space. You could measure the whole thing as face work if you wanted to. Do it as an extra over. Excuse me. Can actually grab these shapes, copy them, paste them, and flip them and just drag that into place. Because what you're effectively doing is just drawing shapes called layers over the drawing. And again, this final little section here. So we've marked up all our face work. Let's just make allowances for that little bit of block work. So I'm just going to highlight that that's behind pitched roof and remind myself that it's a cavity wall. Right. So the next thing I would want to do is obviously my deducts. There are two ways of doing deducts. You can either create a tool for deducting out openings, or you can use the cutout tool that's built into Bluebeam. I'll show you both, but my advice would be, until you're a bit more experienced with it, is to actually create a tool to do it. It's a little bit more work once you export your data, having to add and subtract, but I think I've created you one in here. Window deduct half brick area. Now I've used the perimeter tool for creating that particular tool, so that I can just drag from corner to corner. Remember, if I'd have used a polyline tool, I would have had to have gone around each corner clicking, which takes a lot longer. Let's just get rid of these windows. I've gone ahead and deducted them all. And what you can do by way of annotating is, supposing you were going to do a plan girth approach to this measurement and you didn't have a window schedule, and you wanted to work out your openings, you could come out here and do your window deducts. If you hold the shift key and grab each individual window in turn, that one's highlighted, you can tell by the bounding box and the nodes. I've just highlighted that second one by holding shift and clicking it. Let's grab this door. So click on the line so that it highlights. And I've grabbed all my ground floor windows there. So just to differentiate between ground and first, all these ones are now highlighted. I can go up into the properties, and in the label I can just type in ground floor openings, enter, and you can see they've all been annotated with that. So when I get out into my spreadsheet, I can differentiate between the two, and I know what's left are first floor. So if I click and hold Control and individually select the remaining ones, and do the same there, first floor openings. And you'll see we can filter those once we're in the spreadsheet. One other thing we didn't have here is a little circular one. I'll just quickly show you this. This is how you would get around a curve. There are curve tools in there. So take off the square, grab hold of the actual shape you've created, right click and convert to arc, and you'll see that each leg of that can be converted to an arc. And what you'll get is these little control points that allow you to fine tune it or adjust it to whatever. Because it doesn't always render perfectly first time as it did just there, but we've now got the window deducted, that circular window. It's highlighted down here. We can go down and we can just annotate it here. Circular opening, first floor. So there your deducts. One advantage of creating an actual deduct tool is once you've created that shape, you can actually multi-select the deduct and repaste it elsewhere. So for instance, if you had a large fenestration with loads of repetitive windows, you could effectively grab both those shapes there by holding shift. They're both now highlighted. Right click on the last one and click on copy from the pop-up menu, and you'll see that, supposing we had the same windows here, you would just paste them in place. And you can do the same for any tool, feature. It really speeds things up. And the reason I'm showing you this is, if I get rid of those and I basically drag those out, the other way to do deducts is to use the polygon cutout tool. So if you go up to tools, measure, polygon cutout, you see the icon there. It's also over on this toolbar on the right here, but we'll go with this one. And basically you zoom in and once you're in cutout mode, once you go over the shape you're intended to cut out from, it will turn like a sort of a blue colour, so you know where you're deducting from. And again, you can just drag from corner to corner. And the difference between this approach is that it just won't include it in the total of the half B in the first place. So you don't have to do the mathematical calculation in your spreadsheet. There's some advantages and disadvantages to using that. But I would suggest you stick with the actual deduct tool. For the speed that Bluebeam gives you, it's worth just doing the actual measurement. Sort of directly, because it's just so fast. It's just the difference is negligible in my view, but you'll develop your own preferences. But I just wanted to show you something else also. by way of the fact we're using these layers, you may encounter a problem in terms of orders of layers, and what I mean by that is, if we go back to how we were, so let me just highlight the cutout we've made and delete it. Highlight the cutout we made and delete it. In fact, let's get rid of that whole half B and deduct, as well as these ones. And you notice they're just clearing away. And supposing we had gone a different way about this and we'd done our deducts first, knowing we're going to work in that order. Okay, so I've done my deducts. Let's go back and do our half B outer again. Okay, so my deducts are back, my half B's out there again. Now, supposing I had another elevation where I wanted to cut and paste the deducts I just made from this particular elevation. If you notice, I'm going in and I'm trying to grab the deduct I've made, and it just won't let me do it. Instead, I'm clicking on the shape of the half B that I've taken off. You can tell that because this dialog window's popped up here, telling me that that's what I'm trying to select, and you can see around the outside the nodes and the bounding boxes have appeared on the half B shape. That's what I've actually selected, and the reason it's doing that is, as I said before, it's because of layers. If you encounter that problem, the solution to that is, if you click the layer that's causing you the problem, so obviously this half B layer is on top, we want to get out the window shapes underneath. Right click the shape and go into order and click on send to back. Now what that will do is, if I want to grab hold of this shape, it's put the half B layer behind the window layer, so I can now get at my shapes and copy and paste as before. Let's undo that. And just one other difference between using the deduct tool and the cutout tool is, let's just show you the cutout tool again. The difference with the cutout tool is you can only select one at a time. I'm holding shift and trying to click copy and paste, and I'm only getting one of the shapes. So that's the downside to using the cutout tool as opposed to creating a dedicated deduct tool. There is one other slight disadvantage in that if you have the dynamic fill tool enabled and you inadvertently click in that shape, you will actually end up with measurements in the markups list that you won't know what they are, because you've created a markup and you'll confuse yourself because you won't know what it is. I'll try and demonstrate that to you a bit further down the line. Let's just quickly put things back as they were. Get rid of that cutout. Get rid of that cutout. Also, cutout. I didn't click on the shape properly, that's why the whole shape disappeared. Just do undo. Put these back to where they were. So moving on, and things like lintels, wall plates and closers. There's tools for all of these. They're all in their relevant sections. Let's just say we want a cavity lintel for each one of these. What I tend to do is I envisage the bearing and I just superimpose it on elevation. I'll just go around and I will create a lintel above every opening. Just quickly get that done. And again, if all your lintels are the same, you just cut and paste. They're all my lintels. Let's go for a closed cavity. You can see it's quite speedy because we've got the snap to content, snap to double click to finish. Still in the same tool. So let's just finish up with these few labours just to show you how to get your markup data out of Bluebeam and straight into a spreadsheet. So we measured everything we want to measure for now. The tools are self-explanatory. You use them however you want to. As I said, this is not a how to measure tutorial. This is how to use the tools to measure tutorial, and you can either go with an elevational approach or the traditional plan girth approach. It's entirely your preference, and it depends on how you want to work and how you want to get things done. So I've measured everything I want to measure. I'm ready now to get this out into a spreadsheet. So first thing I do, I've obviously got my second drawing there that's got my girth for my splash on it. I've measured off my elevation. I've got everything measured as I wanted to, as I say. So we go to File and we go to Combine, and dialog pops up and gives me the option to combine the PDF files that I've used in this takeoff. So I just click on Add Open Files, and you can see that both the drawings I've used for marking up, the file names have appeared in the dialog box. All I do is click OK, and what Bluebeam does, it spits me out into a third tab where both the previous drawings I've used have been stapled together in one document. You can see there I can navigate back and forth through the pages. It's given it a default name of document 1, so whilst you're still in this tab, File, Save As, and generally it will put you into the destination folder from where the drawings came. Rename it, markups, call it whatever you need to call it, and just click Save. Now, whilst you're still in this tab, this is a good habit to get into. Right click the file name at the top and select Close Other Tabs. Now it's saying to you, would you like to save the changes you've made to these files? These files will be closed. My advice is don't save them, because these were the original drawings that came in the inquiry, and if you save the changes you will just have overwritten original drawings, whereas this approach allows you to maintain the original drawings without any markups made in them. So don't save, they'll go and they'll go back into the file where they came from, and you've now got your markups. So as you can see, 2 pages in a stapled drawing. I've got both my ground floor plan and my elevation, and also in the markups list you'll see that everything I've used and measured from both plans, there's my perimeter and there's my elevational markups. And if you click on any of the items, back, forth, doing whatever you have to do, excuse me, you can they'll correspond with what's on the screen. So it's another way of navigating, and vice versa. If you click on the screen, the corresponding markup in the markups list will appear. So to export into Excel, which is really what we're driving towards, as I think I explained before, make sure that your subject filter is on in this spreadsheet window, and that will put all the tools back in to the order that you'd taken them off in. I think I explained before, if you filter by label it will just jumble them all up and won't make sense in your spreadsheet. So back into the subject. Now where we messed around with these, you can see Bluebeam tends to remember everything, so just be careful of that, because you can auto complete. And final one is so we're ready to export. We're filtered by subject, which is how we want it. So what we now need to do is, there's an icon at the menu and the markups list here that says, if you say hover over it, it will say summary. So pick the drop down arrow and you'll get various options. What you're after is the CSV summary. So one last check just before we do actually export, just for the benefit of showing you. Find our perimeter, click in the girth column and just type in 0.3, and you'll see that that breadth times that measurement has given us our times in. And again, making sure we're filtered by subject. Choose CSV summary. CSV stands for comma separated variables, and it's the way Microsoft treats individual sections of data. You see it in emails and you see it in a lot of spreadsheet solutions as well, but just know that that's what it stands for. When you click on CSV export, you'll get a dialog window pop up, and you don't really need to do too much to this, but what you need to make sure, markups and totals is checked, column headers is checked, include measurement units, that's optional, that just gives you an extra column to show what units you've used in the measure. It used to be the case that in Bluebeam it was in the same column, and I think they moved it out because when you wanted to do spreadsheet calculations you couldn't, because it had the meter squared next to the number. Turn it off anyway, and the rest of it is pretty plain sailing, and just click OK. So you'll notice it's kicked out all our data. Just go ahead and make that a little bit more readable, and then I'll just explain a little bit about what this data means. First thing I always do is separate it all up into its sections, but you can see that the label column with the annotations in it has been exported, and if you look closer, if you look at this 100mm blockwork area in brackets with a 1 in it, that is mimicked here, and basically that is telling you that in this section there's one measurement in that subject 100mm blockwork area. That's actually the measurement there on that line, but that's the total of it. Similarly, as you would see it there, it's the total of the section of that subject, if that makes sense. Same all the way down. Cavity lintel, there are 9 of them in that section. You can see there's a count of 9 there, but it condenses them all together. Also with the perimeter at DPC level girth, I actually put a breadth in there because I was intending to use that as 4 courses of facings splash for the half B, and it times the girth by that 0.3 and gave me my timesing there. So it's a little bit confusing, but what you also need to know with this timesing, if you look on there, Bluebeam doesn't export the formula, so be aware of that. If you're expecting it to export the formula, it won't do. And it will also add up any breadths and give you a total there as well, which you don't really need, but it's just the way the software works. So it all looks a tiny bit jumbled still, but if you leave Bluebeam to its default and you have all the columns on, you'll have 30-40 columns full of data, and they just will not make any sense, or they'll be a nightmare to decipher. So that's why I keep the columns to an absolute minimum, because all we need to know, the most important thing, is the measurement of the subject. So just by way of tidying up, just get rid of these for now. We don't really need them. There's nothing in breadth that we need at the moment. I'll come back to that damp in a second. So what I generally do is highlight the column by pressing shift and space, and then hold down shift space control, and it will give you some gaps, and drag that to the bottom of the stack. There's one poor feature in Bluebeam, is that it puts the totals at the top of the stack. We are part of the beta tester program, and we've been trying for ages, every time we do an update, to get this behaviour changed or give us an option to move it to the bottom. I think they've actually started to listen to us, so hopefully when it comes out in a future update, we'll have something to we'll be able to use. Again, highlight it, hold the shift key and the space bar, then hold control shift, click on your plus sign, and you'll get some spaces there. Just go ahead and do all of this. That length we use there, that was just our calibration check line around that doorway, if you recall, 2.1. Go ahead and get rid of that. And it's becoming a little bit more bill-like, as you can see, but again, it's entirely down to your own preference how you use Bluebeam to measure. I'm just showing you how to measure with using the tools, and how to get the data in and out, so that you can then further manipulate. Almost there, and we now have one more to go. to make it a little bit more clear. Okay. So just moving on, as you know, we opted for physical deducts being measured. We created a measurement deduct tool. So in our manipulation of this data, these are our deducts. I always just turn them into red so I know that they're a deduct. And again, we split them between first and second floor, ground and first floor openings. So again, you can just go into data and it will split all the different ones out. And you can go ahead and retotal those. So you know which deducts are which. Should you have gone down the route of mean girth times height for ground floor, deduct the ground floor openings, mean girth first floor, deduct the first floor openings. How you measure a site is entirely up to you. I've got my perimeter girth, so I'll measure my splash, my tray damp, and my underfloor vents here in the data sheet, in the actual spreadsheet itself. And I'll just go 0.3, 0.45, 2.25. Obviously this is a through the wall measure, and we need to take our deducts from below. Now I only did one measure, so I'm taking them all at one. But this is just my way of doing it. You know, you can do however you see fit. Equals that minus that. But also, if you'd gone down the route of using the polygon cutout, you wouldn't have to do this deduct calculation because that area would already been had the windows deducted from the running total. What else can I show you? Don't forget that 100mm blockwork was the cavity wall behind the pitch roof, so that will need bringing into this measure. So you could say have a separate measure for cavity and insulation, and 100mm inner skin cavity wall, and make the necessary adjustments here. So that would be the same as that. That would be the same as that. But this would also need that deducting out, adjusting that, and then you'll need 100mm outer skin. Again, I just keep banging on, it's how you measure is entirely up to you. I'm just showing you the way you can use Bluebeam to do it. One other thing I wanted to show you here, lintels. How I do my lintels once I get them into Bluebeam. Generally, if it's just a house bill, a housing bill, I mean it's an average of whatever per linear metre per lintel. So the total is just times by the linear metre rate for the lintel. If you want to drill down into proper detail, another way of looking at that is take the combined girth, cavity trays to lintels times 0.45, that will give you. And what I tend to do is grab hold of all the different lintel lengths. Highlight them, right click on format cells, and just change the decimal place to 1. That simplifies it and brings it to the nearest 100 mil for lintels. And you, as I said, Bluebeam is so accurate to the millimetre, it makes very little difference. And you can then round up or round down. So I then grab the data, I then go to data sort and change them into an ordered list, and you can separate them out to show the different lengths just by inserting columns, insert sheet rows. I've got 2 at 2.3 there. Insert. I will round that up to 2.2, so we've got 2 there, and I will make that 1.2 and I will make that 1.4. So I'm rounding up. And then just totalise your lintels like that using the count function. So it's 2 number 1400 lintels, it's 2 number 1200 lintels, so on and so forth. I'm sure you know how to use a spreadsheet. So you get your measure in some sort of semblance like a bill that you can then go on and manipulate further to get your price. But the real big thing of exporting from Bluebeam into spreadsheets is going back to that CSV file type. Now currently we are in a CSV file type, and if you exit this or just save this as is without saving it to Excel format first, all your data will just revert back to a CSV list. So it's very important that you always change the file type by save as, change it to Excel. It will keep both copies. If we look here, you can see that's the CSV file there, and incidentally that's what it would look like if you didn't save it as an Excel file. That's your Excel version of it. So that's a very important step to get under your belt, and remember to do that on every spreadsheet you export.